Welcome to the Math Record. Today I'll be covering the ICTM Regional 2019 Division AA Precalculus. I'll only be covering question number 9 and number 13 in this video. And then in the next part, for the same contest, I'll be covering number 17, 18, and 19. As usual, I'm going to scroll down so you can answer these questions by yourself if you want. And that's all 20 questions, okay? So let's begin. Number 9. Andrew and Brent will take turns rolling two fair standard dice until one of two things happen. Andrew gets a sum of 6 or Brent gets a sum of 5. Determine the probability that Brent wins when Brent goes first. Okay, so let's make a probability chart or like basically a possibility chart. So we have two dice, so the rows or column could be one dice and the other one would be the other dice. So we have, since a dice is a six-sided, we have 1, 2, 3, 4, 5, 6. And then we have 1, 2, 3, 4, 5, 6. Okay, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And have you ever seen this table before? Basically, the diagonals are all the same, so it's gonna be 2, 3, or you could just fill it out by just looking at it. 5. This is 6. 7, 8, 9, 10, 11, and 12. So what's the probability that Andrew wins? Well, the probability Andrew wins is when he gets a 6. So we have 1, 2, 3, 4, 5. So we have 5 out of the 36 possible combinations. What's the probability that Brent wins? Well, Brent needs to get a 5, right? So 1, 2, 3, 4. So that's 4 out of the 36 possible. Okay, so we think about it, we could think about these as rounds. So what's the probability that Brent wins the first one, or he wins the second, or he wins the third, or he wins the fourth, etc., right? Into infinity. Because what needs to happen is Brent needs to win the first one, or he loses the first one, and Andrew loses the first one, and then Brent wins the second. Or you could have Brent lose the first, Andrew lose the first, Brent lose the second, Andrew loses the second, and Brent wins the third. So so either he has to win or they both lose and then he wins. So the probability that that's going to happen is 4 out of 36 for him to win the first round. For him to win the second round, they both had to lose the first one, so it's 32 out of 36. So Brent has to lose, and then Andrew has to lose, so 31 out of 36, right? And then Brent has to win. Or if Brent wants to win the third round, he has to lose the first, Andrew has to lose the first, Brent has to lose the second, and Andrew also has to lose a second, and then Brent finally has to win the third, right? So based on this, what we could see is that it has a first term for all 36 that's continually being multiplied by these numbers, and they're kind of repeating in this pattern. 32 times 31 over 36 over 36, and there's two of them. And what you recognize is that this, if you write this for contest 4, contest 5, you kind of see that this is an infinite geometric series. So we could rewrite this as the summation as x equals 1 to infinity of 4 over 36, because that's your first term, times your common ratio, which is 32 times 31 over 36 times 36 to the power of x minus 1. Because x, if you put in 1 here, that's 1 minus 1 equals 0. So anything to power 0 is 1. So 4 over 36 times 1 is our first term, so it makes sense. So this is the formula. And the formula to get the sum is just the first term over 1 minus the ratio. So our first term is 4 over 36. So 4 over 36 divided by 1 minus the ratio, so 1 over 32 times 31 over 36 times 36. And since there's just a bunch of numbers, let's just put this all in our calculator. So 4 over 36 divided by 1 minus 32 times 31 divided by 36 over 36. And we should get an answer of 19 9 over 19. And that's our answer for number 9. And that's basically all you have to do. You just need to recognize that it's a infinite geometric series. Number 13. On and Ella are trying to meet at a library. On could arrive between 3 p.m. and 5 p.m. and stay for 17 minutes. Ella could arrive between 3:30 p.m. and 4:30 p.m. and stay for 34 minutes. Determine the probability that they were at the library at the same time. So what we could do is basically, if we think about this as like a chart, let's just say we have a graph. Oops, sorry. We have a graph, and we have on the x-axis and Ella on the y-axis. And let's just say you plot a bunch of points, right? And see if those points make sense. So let's say on arrived at like 3 p.m. Actually, let's say 4 p.m., right? And Ella arrives at like 4:04, right? Do they meet? Well, yes, because On arrived first and she will wait 17 minutes. So she will go until 4:17, but Ella arrives at 4:04, so it's earlier. So they're gonna meet. So that works. So basically what happens is that until once we graph the entire thing with all these points, we can find the area. So let's say there's an infinite amount of points. We can find that area over the entire area, which is constricted by these bounds. We could have that area that we want divided by the total area to get our probability. So to do that, let's kind of set up a proper graph. So that was just a prerequisite of what we're going to do. And now we have On, and we have Ella. So where do we start from? Well, we could start from 3 p.m. to 5 p.m. So let's say 3 p.m. is at 0 minutes, and say 5 p.m. is at 120 minutes, which makes sense, right? Because that's just 2 hours later, so 120 minutes. Now we could, but Ella doesn't arrive at the same time, right? She's from 3:30 to 4:30, so that's an hour, but it's at a different starting time too. So what we could do is that we could just make a bound and make it as a rectangle. So something like this. Okay. And we have, so since 0 minutes is at 3 p.m., 300, at 3:30 p.m., that's at 30 minutes. So that tells us that for 4:30, which is 1 hour later, is at 90 minutes. And then we could just say the other 5 hours 120, right? So it's the same thing. It's a 120 by 120, but they arrived at different times. So this is our bounded region. So this is our total area. So now we just need to find the area which they can meet. So first, we need to figure out which one arrives first. And we could do that by splitting up the graph by y equals x. So we can have a line and y equals x. So somewhere like around here, probably. Actually, somewhere around there. Okay, and that's y equals x. Because if you think about it, let's say there's a point right here, and let's call that like 30. Actually, no, let's call that like 60, 60. Okay. Say they both arrived at 60 minutes later from 3 o'clock, so they arrived at 4. But imagine instead of 60, 60, now it's a little bit higher, so let's say 60, 70. So On arrives at 60 minutes later, and Ella arrives 70 minutes later. So On arrives first. So that means this tells us that this area above here is when On arrives first, because then that tells us that she could wait for 17 minutes. Or if Ella arrives first, which is this bottom section, that means on this bottom section she will wait for 34 minutes. So we could split this up into parts and see how this works. Okay, so let's just use red for On. So if On arrives first, she could wait for 17 minutes. So if she's waiting for 17 minutes, then we could just have some kind of like lines, right? And each of these lines length are 17, right? And this goes on for like a bunch of lines. And you start to realize that we could just draw a line at the tips to each of the tips of those lines, and we get another line. And since they're even amount lines, that means this red line is parallel with this white line. So let's just kind of, and it's a distance of 17 away. So you could probably guess what the equation is going to look like. So let's say somewhere right here. And that is y is equal to x plus 17, right? It's the same slope, but it's just 17 up. Okay, now we have to do the same thing for when Ella arrives first. So let's use blue. So when we were working with On and she has to wait, she stays at the same time while Ella's time could be anything above, right? So then if we're doing what Ella stays the same time, for her to stay the same time, it has to move this way. So that means now instead of 17 minutes, we're moving at 34 because that's what On is waiting at. So it's 34 every single time and it's going this way. So it's twice the distance, so let's make it twice as long. So something like this, right? Let's make it a little bit longer. So what you're going to start to notice is that if you kind of draw a line, it's going to be like this, okay? And it's got to be past this point. You might not know it, but you're going to start to realize because if you make the equation of this line beforehand, what you figure out is that the equation is y equals x minus 34. And the reason is because if you kind of do this, right, and you make a line, right, it has to be going negative. It's definitely not going to be positive. So it's x minus 34 because it's a distance of 34 away. So then when it's minus 34 and you plug in, this is 120 in here, this is going to come out as 86. So y equals 86. And this is 90, right? So at 120, which is what we're bounding at, it's got to be below that 90. And that's why the line is going to be below that. It's not going to be here, but instead here. So that's just a simple explanation to it. But there's drawing a picture is always trial and error for like math contests. So just take your time and it should be fine. So we have something like this, and I would just move it down. So something like that as our graph. And now we have points of intersection, which we're looking for, because all this area works for when On is earlier than Ella, and all this works when Ella is earlier than On. So we just need to add those areas together, or because this looks a little difficult, we can find the areas of these two sections, add them together, subtract it from the total area, and then we could get this area. So what we could do is first we need to find our points of intersection. So we need to find this point, this point, this point, and this point. Okay, so this point is just x plus 13 equals 30. So x equals 13. So this distance over here is 13 because we just need to find the area of this region. We don't need to actually find the points. So now we need to find this distance, which is just this x value at this point. So x plus 17 is equal to 90. So x is equal to 73. And this height is a height of 60. So the area of this, which is just a trapezoid, is just 13 plus 70 divided by 2, then multiplied by 60. Okay, now what's this? Well, this is y. I forgot to write the equation. Y equals x minus 34. And we could say that this is when y is equal to 30. So x minus 34 equals 30. So x is equal to 64. So this distance is 64, so to get to 120, we need to go by 56 as this distance. Now, what's this height? Well, we know that when we plug in 120, as I did before, this height equals 86. So to get from 30 to 86, from here to here, that is a distance of also 56, which makes sense because this line is a slope of 1. So if this is going by 56, this is also going by 56. And now the area of this triangle is just 56 times 56 divided by 2. And what's this entire area of this yellow region? Well, that is just 60 times 120. So our answer to get the probability, first we need to get this area. So that is these two areas. So that is, let me delete her name because I need room, or I could just move it up. Okay. we could just have 60 times 120 minus the two areas that we need to add together, 13 plus 73 over 2 times 60, and then make another bracket. Plus the area of the triangle, 56 times 56 over 2, and, oops, wrong bracket. And then that is the area of this region over the entire probability, which is just 60 times 120. So let's just do that in our calculator. So 13 plus 73 divided by 2 times 60, and then 56 times 56 divided by 2. Add those two together, and, oops, I wrote this wrong. And multiply by 60. Okay. Add those two together, and you should get the area of the this and this added together is 4148. And then you should have 60 times 120 minus 4148 divided by 60 times 120. And you should get a value that's 763 over 1800. And that's your answer for number 13. Well, that basically covers part 1. I'll see you part 2 if you want to find the answers for 17 through 19.